Assalamu alaikum and good day everyone. Now let's continue our lesson to moving blocks to create familiar forms. So previously you have learned about a few forms, familiar forms for these block diagrams. We have a cascade or series subsystems where this is the simplest one. And then next I have explained to you about the parallel subsystems where we have the pickoff points here. And then we have summation, summing junction at the ends of these parallel subsystems. And then next one we have a feedback form. So feedback form here is actually it's kind of a closed loop transfer function. You can find closed loop transfer function from this feedback form. So now we will embed all those block diagrams where we can move the blocks to create a family of forms to solve and to find the simplified version of the block diagrams. So the first one we have A here. Okay, this is we have a summing junction. Okay, we have a summing junction over here. And then we have an input and we have another kind of maybe feedback path coming into the summing junction. And then past the summing junction we have a subsystem of GS, and then we have the output of CS over here. So we can move the summing junction at in front of the subsystems, or in other words we can move the subsystems behind the summing junctions. So we can try to say that this is the equation for the CS. So we can say that the output here is the CS here is actually some combination of GS, and then we have input from RS coming from the input, and then we have another one is XS. Okay, this is the CS. So on the right hand side we can have the output CS is actually it is a summation of R, S, G, S, and then we have another input here. So this is a minus plus, so it's minus plus over here, and then we have X, S, G, S. So we can factorize GS so that we have inside is RS minus plus XS. So we have shown that the left hand side and the right hand side, okay, both have a similar output of CS. Okay, so meaning that these two block diagrams is similar to each other. Okay, the way it represents can simplify our task to create a more familiar forms. Okay, the next one we have similar forms, but this time around we have the subsystem, and then in front of the subsystem of GS here we have summing junction. We have the summing junction. So let's find the CS over here. So we have CS equals to, this is a summation of RS, GS minus plus XS. Okay, so let's try the right hand side, the blocks. Over here we have CS is actually a GS, and then we have over here we have RS minus plus, we have XS over GS. Okay, so we can simplify this form. We can have here is GS RS minus plus of so XS. Okay, so now we have similar form between the left hand side and the right hand side. So here we have RSGS minus plus XS. Over here we have RSGS minus plus XS. Okay, so we have shown that both forms are equivalent to each other. Okay, so now how to memorize this one? So you can take any method that is familiar to you. So you can say that after, or if you're moving the subsystems, to the backs, so you will have both subsystems, similar subsystem GS and GS. If you move the subsystem in front of the summing junction, you will have GS and 1 over GS. Okay. Next, we have this is peak off points here. So for the peak off points, okay, so now we have RS as an input here, and then we have 3 branches, 1, 2, 3, and then we only have GS at the first branch over here. So the equivalent block diagrams is we move the block diagrams of the subsystem GS at the besides input. So what happened is that it becomes something like this. We have GS over here, and then another branches we have 1 over GS and 1 over GS. So let's find the for this one. Actually we have over here is, yes, this is the output here is RSGS. So here is RS, here is RS. Okay, so similarly at the equivalent on the right hand side, we have here is RSGS, this one is RS, this one is RS, because GS multiply with 1 over GS, so you can cancel out. Now you only have RS here at the output. Okay, similar to this one as well. Okay, the next one we have RSGS, the pick off point here. So the output at the all branches is equivalent to RSGS, RSGS, and RSGS. So if we move the blocks to the branches, okay, so what we have is on the right hand side here, it becomes every branches will have GS, GS, and GS here, and then the output is still equivalent to the left block diagram, which is we have the output of RSGS, RSGS, and RSGS. Okay, next one. This is the block diagram transformation table, table 2.6 here. So you can refer to this table to help you to answer the questions. Okay, so here is number 1 is very simple one. This is the cascade In this case, we just multiply G1 to GS, and then we will get G1 GS, G1 G2 over here. Okay, and then I have explained to you just now number 2, 3, 4, and 5. And then I have explained to you as well number 6 yesterday, where we have this kind it is in the form of feedback loop. So you can simplify the block diagram of the feedback loop. You can just use the formula that we have found yesterday. We have derived yesterday, which is you can take the subsystem here, G over 1, in this case a plus minus at the summing junction here. So we have 1 minus plus of G and H. Okay, so you must take I want to emphasize you on the sign here. Remember yesterday we have different sign between the summing junction. Over here is plus minus, but whenever you do the feedback, what you have is we have minus plus. It is different from the summing junction. So take note on these signs whenever you simplify the feedback loop of a block diagram. Okay, let's go to the example 1. Okay, we have here reduce the following block diagrams to form a single transfer functions. So we have we can use different approach to solve this problem. So one of the solution is the first one. We can have a very simple one. We have a cascade version of a block diagram here. Okay, this is a cascade. And then another one, we have a summing junction over here. We have summing junction we have here. So we can simplify the summing junction. So we can, let's take a note on the sign over here. So this is minus, plus, minus. So here as well, minus, plus, minus. Okay. So we reduce 3 of the summing junction into 1 summing junction altogether. And then next what we can do is we take the cascade of the block diagram. We have G2 and G3 over here. And then we can simplify the summing junction over here. So we have here is let's see the symbol. Okay, so this is minus, so this is actually minus. So this is minus, the the symbol outside is minus, so it is actually minus H1, and then we have positive H2, so minus becomes positive H2, and then another one we have here is minus H3. Okay, so here is a minus plus equals to minus H3. Okay, now we have a familiar form of loop or feedback feedback block diagram. So there is another one left here. So we can find the what we call it feedback block diagram. We can have something like G3, G2. Okay, so we have one here is minus, so we have plus. So we have plus, we have G3, G2, and then we have H1 minus H2 plus H3. Okay, so we have here another one. We have a blocks G1 over here, so we multiply by G1, so it becomes G1. So we get the simplified block diagram as shown in the notes here. See. Alright, let's move to example number 2. So this is actually quite complicated as compared to the previous example 1. So in this case, we have can identify which one we want to reduce first. Okay, we can have this one in the form of feedback, and then you can see here there is a summing junction over here. So this is a summing junction, so we can move the block diagrams here to behind the summing junction, so that we can have cascade version of G1 and G2. Okay, let's go one by one. Okay, the first one is this. We can reduce of this loop or feedback block diagrams here. We have G3 using the formula 1. So let's look at the sign here. So it is actually minus, so becomes 1. Alright, so we have we have G3 over 1 plus G3 H3. Okay, and then we have here, we move the G2 to behind the we're not moving the G2 actually. We are moving yes, we are moving G2, not behind the summing junction. Is actually a peak-off point here. So we are moving G2 behind the peak-off points. So we can refer to table 2.6. So in this case, behind the block diagrams, behind the so we are moving this. Okay, so it is number 4. This is number 4. Okay, so in this case, we push the G2 over here. So you originally is here, so we push G2 here, and then there is a branch above here, so we have 1 over G2. We have 1 over G2, and then what we have here is something like this. So basically we can move the lines here is something like this, so we can just ignore this one. Okay, so right, so what we have here is this is a summing junction, so it becomes here. So we have 1 over G2 plus, this is actually 1 if there is a signal there without any subsystem, so we can assume that there is a unity signals there, so it's equal to 1. So that's why we have 1 over G2 as plus 1. Okay, next one, we can move G1 in front of the summing junction. So when we move in front of the summing junction, you can refer to table 2.6 here. Okay, we move in front of the summing junction, so let's look at number 5. Okay, So what we have is we have G1, G2, and then H2 over G1. Okay, and then we can find this is two summing junction over here. Okay, this is two summing junction. Basically, we can combine both summing junction into single summing junction, where we have H2 over G1 plus H1. So take note about the sign at the summing junction over here. And then this become very familiar. So this is actually a feedback block diagram. So we can solve this feedback block diagram here to this form, and then we have this is the original one, and then we have a simplified version, a cascade or series version of block diagram. So we can multiply both subsystem 1 and subsystem 2, so we will have a final simplified version of this block diagram, something like shown in figure E over here. Okay, this is the alternative solution that you can use to solve this kind of problem. So in this case, it's instead of moving the G1 in front of the summing junction, you can simply take the feedback of this G2 and H2. So you will have a single a box subsystem over here, and then you can multiply with G1, and then you have another feedback form. So you can try yourself if you can understand this alternative solution. Okay, see you in the next lecture.